This meeting is being recorded.
Okay, very good afternoon, all of you. Screen is visible.
Yes, sir.
Okay, so what we have studied in the last lecture, that is different types of MOSFET. Okay, depletion type and enhancement type. These are the major two types of MOS transistors that we have. And again, it has N channel and P channel, right? For each type, again, there is a subtype: N channel depletion type MOSFET, P channel depletion type MOSFET. Same for the enhancement type also: N channel enhancement type and P channel enhancement type. Okay, so in today's lecture we are going to cover uh, N channel depletion type MOSFET and P channel depletion type MOSFET. So you can see the diagram on the screen. It is showing the N channel depletion mode MOSFET, or you can say N channel depletion type MOSFET. Okay, so all of you are aware of, as the MOSFET has mostly three terminals similar to your BJT. Of course, there is a much difference between the MOS transistor. The comparison we have made in the last lecture, and uh, for the fast switching, or what you can say, for the fast switching application, MOSFET is always preferred over BJT, right? And where BJT is preferred, so where there is a what we can say, some high voltage applications, there you can say BJT is preferable. Okay, now talking about the N channel depletion mode MOSFET. So what is the structure or construction of this N channel depletion mode MOSFET? So as you know, we have a three terminal: source, gate, drain. Okay, so metal contacts are made to connect towards inside the or to connect the inside layers of the MOSFET. So source and drain are doped, right, with N type dopant. Okay, uh, have you clear with the N type dopant and P type dopant? Or in a simple language, you can say P type dopants means what? The pentavalent pentavalent doping agent, and N type are normally trivalent doping agent. Now, what is pentavalent and trivalent? It is a very basic of physics, and or you might have learned in your ECAD also. Okay, so which dopants are normally used for a N-type dopants means what? N-type dopant is nothing but trivalent dopant. So which is used as a N-type dopant or trivalent dopant? Can you just name two or three dopants that you know to make this? First, why we are doping? To make the intrinsic, that means very pure type of semiconductor material, to extrinsic. Extrinsic means what? Which having the impurity. Doping is nothing but adding some impurity in the pure semiconductor, that is silicon. Okay, that forms the depletion region and all that process that you know how diode or transistor working. The same, more or less same action and working principle is the with MOSFET also. Okay, so basically for N channel, as the name indicates, N channel depletion mode, that means what? The dopant or the impurity that we are adding is of N type dopant or trivalent dopant. Okay, now you have a P type substrate. Okay, so between that N type dopant add between the source and drain and over a P type substrate, right? So there is a formation of diffusion region or diffusion channel. Okay, now first tell me, what is difference between the depletion MOSFET and enhancement MOSFET? What do you think?
So depletion is normally on MOSFET.
Yes, and enhancement is normally off MOSFET. Means what? Again, you can refer this. VI characteristics of this depletion times. See, at zero voltage means what? You have applied nothing. Then also you are getting some current here. Here is you are getting some current value. That means on x-axis value is zero, but y-axis value you are getting something. Means what? At zero voltage and on x-axis what is there? Voltage. On y-axis what is there? Drain current. That means the VI characteristics clearly shows for a depletion type MOSFET at zero voltage, you are getting something on y-axis, and that means the ID value. That means what? At zero voltage also you are getting some quiescent current. That's why this type of MOSFET is known as normally on MOSFET. If you talk about this enhancement type, you can clearly see at zero voltage, the current is also zero. There is no value for current. When voltage slightly increases, then the current start flowing, right? That's why this enhancement type MOSFET is called as normally off MOSFET, and depletion type MOSFET is called as normally on MOSFET. Okay. I hope you have clear with this. So again, coming back to the N channel depletion mode. So basically the P type semiconductor forms the substrate. That means it's an intrinsic material that we are using, a P type semiconductor. And on that P type semiconductor, we are adding the N type impurities or N type dopant, or you can say N type dopant means normally a trivalent impurities. Trivalent means what? In the outer orbit of the octet, there is a 3 electrons are less to complete the octet. That's the trivalent impurity. And pentavalent means what? To complete the octet, there is a you need a more 3 electrons. Sorry, and for a trivalent, you need a more 5 electrons to complete the octet. Okay, so that is basically difference between the so that is basically difference between the uh, trivalent and pentavalent octet. Okay. In case of n channel, in case of n channel, you can p-type semiconductor. On p-type semiconductor, you are adding the n-type impurities. This is the first thing. Now, the gate voltage applied is negative. See, for depletion MOSFET, whatever the gate voltage we are applying, it is a negative voltage, and the channel is depleted and it's free electrons. As it's n type or as it's n channel, means what? There is a majority carriers as a electrons, right? For a p type, majority carriers will be holes or positive element, right? So now you have clear with all these terminologies and basics from your ECAT. So this is about the N channel depletion mode MOSFET. What it differs from the P channel depletion mode MOSFET. So now you can see the only thing is, now in case of P channel depletion mode MOSFET, we are using the N type substrate, and in that N type substrate, we are adding pentavalent doping agents or pentavalent impurities, right? That forms the P type. Okay. Here by mistake, I have written N type, but it should be a P type impurities. Okay. So this N type semiconductor forms a substrate, and the source and drains are heavily doped with P type impurities. Okay. This applied gate voltage is positive. In case of P channel, applied gate voltage is positive, and in case of N channel, applied gate voltage is negative. And obviously, as we are adding the pentavalent impurities or p-type impurities or p-type doping agent, the more number of free holes are available, and that will be the majority carriers. That will be the majority carriers. See, as you know, MOSFET is a unipolar device, right? As I have explained to you, unlike a BJT, there is a no minority carriers in case of MOSFET. Okay, as a BJT, there is no concept of minority carriers in case of MOSFET, as it's a unipolar device. The in all current contribution is because of only and only majority carriers, and that's why it is called as a unipolar device. In case of BJT, there is a, or the total current is contributed by the majority as well as minority carriers. But in case of MOSFET, you should always remember the a total current is contributed by only majority carriers as it's a unipolar device. Clear with this? So this is about the N channel depletion mode MOSFET and P channel depletion mode MOSFET. Now, this is the diagram and the circuit of the N channel depletion MOSFET. Okay, so as you can see here, we are using the P type substrate. In that P type, we are doping the N type impurities that forms the channel. We have to apply negative voltage to the gate. Okay, this is the gate terminal. So we have applied here. You can see here, we are applied here a negative voltage to the gate. Source to gate is a uh, or the negative voltage towards the gate, and here is the VDS, drain to source voltage. So this is what the connection for the N channel depletion MOSFET. Okay, now what are the operating regions of the N channel D MOSFET? Okay, what are different operating regions for the N channel depletion MOSFET? So uh, first you have a cutoff region. Okay, what is condition for this cutoff region? So in this region, gate source voltage, that is VGS, is very less than or equal to minus VTH. Why minus VTH? Because we have applied the negative voltage to the gate. That means threshold voltage is minus. So there is a no drain current, ID is 0, regardless of the value of VDS. So irrespective of whatever the voltage you have applied for the drain to source, it's a what we can say, irrespective of that, unless and until the VGS is less than minus VTH, the current will not flow. That means ID will remain 0. Okay, this is about the cutoff region. Now saturation region, or you can say linear region or ohmic region, right? In case of MOSFET, linear region and ohmic region is one and the same. Okay, so don't get confused between the linear region and ohmic region. For a linear region, what is condition? Now the VGS is greater than minus VTH. VGS, gate to source voltage, is greater than minus VTH, and VDS is less than V minus P, right? Or V minus P. That means it's a uh, drain to source voltage is less than V minus P. The MOSFET acts as an amplifier in this region. The current ID increases with the VDS while its amplification depends on the VGS. Right, its amplification depends on the VGS, as you are aware of the VI characteristics. That means what, why it is called as a ohmic region or linear region? As the VGS increases, ID also start increasing. That means what, it's there is a some sort of linear relation between the VGS and ID, right? There is a linear relation between the VDS, VGS and ID. Okay, that's why it is called as linear or ohmic region. Now saturation region, the third region. First one is the cutoff, middle one is the linear or ohmic region or amplification you can say, and the topmost region is saturation region. Now what is condition for the saturation region? So in this region, VGS is greater than minus VTH and VDS is also greater than V minus P. VDS is also greater than V minus P. That means if you still increase both voltages, the N channel depletion MOSFET will go to the saturation region, right? Now what happens in this saturation region? It allows a maximum drain current, right? At saturation region, it allows the maximum drain current to flow, that is IDSS, and that is again depends on the VGS. That is again depend on the VGS. But can we say the still you increase the VDS and VGS value, the current will goes on increasing only? No. In case of MOSFET, there is one condition. It is called as pinch off condition. That means what? Now you though increase any voltage, VDS or VDS, the ID will remain constant. That condition is called as pinch off condition. Okay, so there is a maximum drain current. Yes, obviously it will flow in the saturation region, but up to what limit? Up to, unless and until the MOSFET will reach to that pinch off condition or that pinch off region. Until that point only your ID will get increased. Once it will get to that pinch off condition, it will remain constant irrespective you increase any voltage. Okay, this is very important condition that you should remember. Okay, so this is about the n channel depletion MOSFET. Now similarly we can talk about the p channel depletion MOSFET. Okay, now this is the circuit. As you know, for the p channel we are providing the positive gate voltage, so we have connected the positive terminal of this battery to the gate. Okay, n type substrate will be there. In that n type substrate, p type doping agents or p type impurities we are adding to form the p channel depletion MOSFET. Okay, similarly it also has three operating regions: cutoff, saturation and linear. Always remember, you go for any kind of MOSFET that may be a n channel or p channel depletion or enhancement type, there will be a three region of operations. At the bottom side you have a cutoff region, middle one is a linear. uh, some
मी बी समृद्धीत
someone
त्यांच्या
has
गाडीकडे उभे होतो.
someone has
मारा लागले
unmuted.
म्हणलं कसं उभे राहिलो. खाली जाऊन बसलोय इथनं. ते मारायला लागलं आणि थांबलो. खायला तेच त्याच्या पाठीमागे लागलंय ना किंवा कोणाच्या पाठीमागे.
Don't disturb me. Okay, it's a request. Someone has knowingly or unknowingly turned off his or her mic, so it's create a problem. Okay, better take care of all these things. Okay, again coming back to the operating regions. Okay, so always remember, any kind of MOSFET, any kind of that may be a depletion type or enhancement type, doesn't matter, p type or n type, that also doesn't matter, will have a three region of operations: cutoff region, saturation region and linear and ohmic region. Linear or ohmic region, that is one and the same thing. Actually MOSFET will act as an amplifier in this linear or ohmic region. Okay, now what is the what are the condition for this p channel depletion MOSFET to be in a cutoff region? What are the conditions? So condition is the VGS, right? VGS should be less than VTH or it is equal to VTH, right? It is less than or equal to VTH. Now here in this case, as it's a p channel, VTH is positive, right? So VGS is less than or equal to VTH. There is a no drain current. That means current will not flow. ID will remain zero regardless of any value of VDS. This is a switched off, or it is a will not start flowing any current. Okay, this is the cutoff region. Now saturation region. What about saturation region? So in case of this saturation region, VGS is less than plus VTH and VDS now will be greater than V minus P. The MOSFET will allow the maximum drain current in this region, and again which is depend on the voltage that you have applied to the VGS, gate to source. Okay, this is about the saturation region. Now what about linear or ohmic region? So in this region, VGS now it is a less than VTH and VDS is also less than V minus P. The MOSFET acts as an amplifier in this region. The current ID increases in respect to the VGS and VDS, while amplification depends upon the VGS as shown in the VI characteristics. That means what? Now you have applied some threshold voltage. VDS is still below the VP, V minus P. The MOSFET will enter into the linear or ohmic region and it will act as an amplifier. In this region, the current ID also start increasing depending upon your VDS value, and The amplification is depending upon the VGS, how much voltage that you have applied on the VGS, right? So this is about the P channel depletion MOSFET. These are the operating principle of P channel depletion type MOSFET. Okay. Now coming to the next type, enhancement type MOSFET, or which is uh, called as a normally off MOSFET. Why normally off? Because at a zero voltage there is a no current, no drain current, right? That's why it's a normally off MOSFET. Okay. So as you know, in this mode there is a no conduction at zero voltage, which implies it's a closed. That means, or in a other language, the n type, or sorry, e type MOSFET, that means enhancement type MOSFET, also called as closed switch, because there is a no current flowing, right, without any application of voltage. And depletion type MOSFET is called as open switch, because there is a some quiescent value, though you have applied not any voltage. That's why it's normally on, depletion type. And enhancement type is normally off MOSFET, or you can say it's a closed switch. Okay. So when the gate voltage is increased more than the source voltage, the charge carriers, that means holes in case of if it's a P channel, shifts away, leaving behind the electrons, and thus it's widen the channel established. The gate voltage is directly proportional to the current. That means as the gate voltage increases, the current increases, and vice versa, right? See here, the charge carriers will be holes. Okay. If it is a P channel, if it is a N channel, it can be a electrons. Okay, depending upon which type of substrate and which type of doping agent that you are using. So again, for enhancement type also, as we have discussed, there is a N channel and P channel. Okay. For enhancement type MOSFET also, there is a N channel enhancement type MOSFET and P channel enhancement type MOSFET. So this is about the N channel enhancement mode MOSFET. Now here the same construction will be there. Okay. P type substrate. Here we are having the N type dopant. Okay. These are the metal contacts, and it's a silicon dioxide insulation, SiO2, right? It's a silicon dioxide insulation. A lightly doped P-type substrate forms the body of the device, and the source and the drains are heavily doped with the N-type impurities. Normally, N-type impurities are referred to the trivalent impurities. Okay. Now, N-channel have electrons as a majority carriers. N-channel have electrons as a majority carriers. Applied gate voltage is positive to turn on the device, right? Whatever the applied gate voltage, VTH, right? That is the threshold voltage, nothing but that you have applied to the gate, it should be a positive. It is lower inherent capacitance and smaller junction areas due to high mobility of electrons, which make it to operate at high switching speeds. Okay. While discussing the differences, we have seen this. The switching frequency or switching speed of the MOSFET is always much greater than the BJT. Okay. It contains positively charged contaminants, which makes the N-channel MOSFET to turn on prematurely. Drain resistance is low compared to P-type MOSFET. These are the some of the specification or characteristics of N-channel enhancement mode MOSFET. This is about the P-channel enhancement mode MOSFET. Okay. So what are the characteristics of this P-channel enhancement mode MOSFET? Again, now as we say it's a P channel, that means what doping agent will be P type. When you talk about N channel, doping agent will be N type and substrate will be opposite to that. So as here is a P channel MOSFET, that means first substrate will be opposite. That means substrate will be of N type and doping agent will be of P type. That means pentavalent impurities. So it has a lightly doped N substrate, okay, to form a body on the device, and the source and drains are heavily doped with the P-type impurities, that means pentavalent impurities. P channel have holes as a majority carriers. It has higher inherent capacitance and mobility of holes is low, which make it to operate at low switching speed compared to the N type. The applied gate voltage is negative to turn on the device. The drain resistance is higher compared to N type. Okay, so these are the characteristics of p channel enhancement mode MOSFET. Okay, again, this is the N channel E MOSFET. E stands for enhancement type. So this is the circuit diagram here. Gate terminal we have connected with the positive as it's a N channel. So we have to applied positive voltage. N channel E MOSFET is this. That's why we have applied a positive gate terminal. Construction we have already discussed. This is the circuit diagram. Now we will talk about its region of operations. Okay, now what will happen or what are the condition so that the N channel E MOSFET will remain into a cutoff region? So for that, VGS should be less than or equal to 0 voltage. So there will be a no drain current. Okay, regardless of the value of VDS, there is a no drain current. So it operate as a switch. Okay, this is the cutoff region condition. Now coming back to a saturation region, what will happen in the saturation region? So in this region, the VGS is greater than 0 and VDS is greater than VGS. Okay, VGS is greater than 0 volt and VDS is also greater than VGS. So MOSFET will allow the maximum drain current IDSS, which depends on the level of VGS. Again, when we are saying the maximum drain currents, but there is a limit, right? There is a limit to that maximum drain current. Okay, that means what? Until and unless it will reach to that pinch off condition, up to that point only the id will increase with respect to vds, but once is reached to that pinch of condition, it will remain constant. Doesn't matter then thereafter how vds will increase. लक्षात येते? आपण जेव्हा म्हणतो की मॅक्सिमम करंट ते अलाव करतंय, ह्याचा अर्थ असा नाही की ते इन्फायनाइट करंट देऊ शकतो. नो, देर इज अ सर्टन लिमिट, राईट? अँड दॅट कंडिशन इज कॉल्ड एज पिंच ऑफ कंडिशन. ते कुठपर्यंत आयडी तुमचा वाढत राहील जोपर्यंत तुमचा मॉसफेट पिंच ऑफ कंडिशन पर्यंत जात नाही. तो एकदा का पिंच ऑफ कंडिशन पर्यंत गेला की तिथून पुढे काय होतं? व्हीडीएस तुम्ही जरी वाढवला तरी आयडी वाढत नाही. तो एका कॉन्स्टंट व्हॅल्यूनी फ्लो होत राहतो. दॅट्स नथिंग बट युअर id max. And when will this id max condition you will reach? At the pinch off condition. Okay, so you have to remember this point. Now the third region of operation is linear or ohmic region. So in this region, vgs is greater than 0, vds is less than vgs. The MOSFET will act as an amplifier. Okay, in this linear or ohmic region, as there is a what you can say linear relationship between the vds and id. Vds increases or vgs increases, id will increases, right? So it's a kind of uh, linear or ohmic region. That's why this particular region of operation is named as a linear or ohmic region. Or and of course, for a MOSFET as an amplifier, you have to operate the MOSFET in this region only. So in this region, the current ID increases with the VDS, while its amplification depends on the VGS as shown in VI characteristics. We have already seen its VI characteristics. Now coming talking about the P channel E MOSFET, that means P channel enhancement type MOSFET. Now, what will happen in this P channel enhancement type MOSFET? So, in this P channel enhancement type MOSFET, gate is connected to the negative terminal. Okay, rest of the as you know, P channel means what? N substrate, and in that N substrate, the P type dopants are heavily doped to the source and drain terminal. This forms the P channel enhancement type MOSFET. Okay, this is the circuit diagram and this is the construction of P channel E MOSFET. Always remember, when I will hereafter when I will see it's a E MOSFET, E stands for enhancement type, and when I will say D MOSFET, D stands for depletion type. Okay, so just note these things. Again, operating region of this P channel enhancement type MOSFET. What are the conditions to operate this MOSFET into a cutoff region? So first of all, VGS should be greater than 0 volt. In that case, there will be a no drain current regardless of the value of VDS. Now, what are the conditions to operate this MOSFET into a saturation region? In case of saturation region, VGS is less than 0 and VDS is greater than VGS, right? So in this saturation region, again, MOSFET will allow or MOSFET will draw the maximum current because the channel form in that in this saturation region will be maximum. So the it can allow the maximum number of majority carriers, right? And that's why the current will also maximum. Okay, but again I will repeat, up to what condition it will allow that maximum condition? Up to pinch off condition, right? Once it will reach to that pinch off condition, it will it will not allow any further increase in the current. That means now the current will remain constant at that maximum value, though you increase the VDS. म्हणजे तिथनं पुढे तुम्ही किती VDS वाढवा, current वाढणार नाही, right? So this is about the saturation region condition. Now what will happen in the linear or ohmic region condition? So in this region, VGS is less than 0 and VDS is also less than VGS. Okay, the MOSFET will act as an amplifier in this region. Now in this region, the current ID increases with the VDS while its amplification depends on the VGS. Okay, that we have talked about the or that we have seen in the VI characteristics of MOSFET. Okay, so this is about the or all four categories of the MOSFET. That means P-type depletion, P-type D MOSFET, D stand for depletion region. Sorry, P channel D type MOSFET, P channel depletion type MOSFET, N channel depletion type MOSFET. Further categories: N channel E MOSFET, E stands for enhancement type or enhancement mode, and P channel E type MOSFET. Okay, so basically these are the four uh, uh, types of the MOSFET. Okay, so this working of MOSFET as an amplifier, so we have already discussed. Okay, so for today we will stop here. In next lecture we will continue with the next topic of our unit number first. Okay, whatever we have studied up till now, if you have any query or doubt, you can ask me right now. Do you have any query or any doubt?
Yes, sir.
Okay, for today we will stop here. In next lecture we will continue with the next bit of unit number first.